Hi, I'm Kajal Kumari, CSIR SRF Research Scholar, working with Professor Mayank Goswami, Department of Physics, IIT Roorkee. In this video, I'm going to discuss my recently accepted research article titled Gamma Radiation Detector Selection for CT Scanner. This is related to study the impact of adjacent radiation detectors on scattering noise in the measurement data and their optimal selection. Here is the outline of this presentation that we will talk in this video step by step. In computed tomography, one may use the number of detectors as maximum as user wants, but limited by CT geometry. The number of detectors decides the resolution of CT system, but the presence of neighbor detector may impact the measurement data due to the scattering of photons from it. So in this work, we study the impact of adjacent detectors on scattering noise in the measurement data and also their optimal selection. For this, an innovative scanning scheme is utilized that creates virtual detectors by displacing it to the next detector position in the scanning area of CT system using a single detector. The more detail about this CT scanning scheme we will discuss in the upcoming slides. If we have different radiation detectors of different crystal materials, then which one will contribute more scattering noise is also studied. This figure gives the visualization of the main motivation of this study. This is the disk source, and these are two detectors placed nearby. So when the radiation is incident on these detectors, then there are chances that the radiation may scattered by the adjacent detectors and may enter into the main detector and detected by it. This is the inner cross-section view of an old radiation detector. Here is the methodology of this work. For this study, we have to utilize a particular radiation detector. But what if we have different type of radiation detectors of a different crystal material is available? Then first we have to find out the most suitable detector. So how we can do that? So for that, first we have to compare all these detectors from the perspective of electronic noise. Then we can utilize it for the main study. For the estimation of the scattering noise present in the measurement data due to the adjacent detectors, we are going to utilize a mathematical tool, contour theorem first. This theorem gives an estimation of the inherent noise present in the projection data of a CT system detected by different detectors. The more detail about this KT first and how it works can be studied in this paper. So the inherent noise is mainly made up of two components, electronic noise and scattering noise. If we use a detector which has relatively minimum electronic noise or low electronic noise, then the variation in the inherent noise will be basically due to the scattering noise. So the estimation of inherent noise reflects the estimation of scattering noise. We will also study the number of adjacent detectors, the impact of the number of adjacent detectors on a scattering noise of the measurement data. Here is the experimental detail. So first if after finding out the suitable detectors among available different type of radiation detectors, the detector which has minimum electronic noise is utilized for the further study. So this figure gives the schematic diagram of CT geometry. This is the gamma radiation source. which is cesium 137 used in this study. And this is the scanning object, which is made up of three different materials. This one is acrylic, and this one is aluminium, and at the center of the aluminium cylinder a iron cylinder is inserted. So first we will use a single detector, then we will displace it to the next detector position. By translating it, we can create the more virtual detectors. So in this way we will not compromise the resolution of the city system by utilizing a single detector. Then we will increase the number of detectors from 1 to finally 5. So in this figure we utilize 2 detectors, then 3 detectors, and then finally 5 detectors at a time. The city geometry of that is utilized that is used for city experiment is also shown here. So first, to find out the optimal detector, we compared the suitable detector. We compared the electronic noise of all the detectors. In this study, we used 3 different detectors: sodium iodide, HPG, and LABR3. For the estimation of electronic noise, we utilize standard deviation parameter. So this figure gives the standard deviation of radiation counts that is measured multiple times. This figure shows that sodium iodide detector has relatively low electronic noise in the measurement data. So this is utilized for the further study. At this point we are assuming that we have at least 5 units of each detector. So among 5 detectors, which one we will utilize this? So we carry out a CT experiment using every single unit of sodium iodide detectors to calculate their inherent noise present in the measurement data. So this figure gives the inherent noise present in the data detected by each unit of sodium iodide detectors. This is the goodness of fit of RMSE that reflects the level of the inherent noise present in the measurement data. So we observe that this unit has minimum inherent noise, so we utilize this unit of sodium iodide detectors. So using this we perform the CT experiment of one detector, then we utilize 2 detectors, then 3 detectors, and then finally 5 detectors. We observed that with the increase of the neighbor detectors, the scattering noise is also increasing. So basically KT first gives the quantitative estimation of scattering noise present in the data. To visualize its impact in real application, we also did the qualitative estimation of scattering noise. So for this we utilize a parameter which is dissimilarity coefficient, and we compared the city images. This is the cyber phantom, and this is the simulated reconstructed cyber phantom. In this, no real data is used, so the noise in this is mainly due to the reconstruction algorithm, which is present same in all these city images because same reconstruction algorithm is used. We are assuming since it is simulated data, so no scattering is present. This is the city images using a single sodium iodide detector. This is when 2 detectors are used, then 3, and then 5. The impact of the scattering noise on city images can be seen in the form of the efficiency and lack of informations available in the city images, which is marked here with yellow and red colors. We also observed the shift of the information of most attenuated part of this scanning object, which is due to the aluminium and iron. So the flow of this shift is shown by these arrows. We utilized transmitted computed tomography. So the presence of the scattering radiations in the photopeak region of the gamma spectroscopy act as unwanted noise. So due to this, we observed these patches in the CT reconstructed images, and this is due to the wrong modeling of CT reconstruction algorithm, without considering the actual path of radiation scattering phenomena. So then we compared the noise level present in the data detected by these different detectors, and this figure shows the inherent noise present in the data detected by using different detectors, and we observed that a relatively low uh, inherent noise is observed in case of HPG detectors, and maximum for the LABR3 detector. The conclusion of this study is as follows. With the utilization of 5 sodium iodide detectors together, we observed 56% more scattering noise as compared to the single detector. So this study suggests that we can utilize a single detector and minimize the level of scattering noise. So it will enhance the CT image quality also, and we can use single detector without using an innovative scheme. We can utilize the single detector, and we can reconstruct CT images without compromising its resolution. And a maximum difference of 85% is observed when different type of radiation detectors are used. Minimum inherent noise is observed in the case of HPG detector. A comparative noise is observed for the sodium iodide and HPG detector, and so a discrepancy of 12% is observed for the case of sodium iodide detector as compared to HPG detector. So, thank you.